Solving 4.27. 4.27 says divide 12.50 into 5 parts in AP such that the first and the last part are in the ratio 2:3. Our parts will be A plus D, A plus 2D, A plus 3D, and A plus 4D. The ratio of the first and the last parts is 2/3, so 2 divided by 3 is equals to A divided by A plus 4D. Cross multiplying it, we will have 2A plus 8D is equals to 3D, and 8D is equals to A. Now we also know the sum. Sum formula is S is equals to N over 2, 2A plus N minus 1 into D. Our sum is 12.50 is equals to, there are 5 terms, so 5 over 2, 2 into A. A is equals to 8D, that we know, plus N minus 1 or 5 minus 1 into D. So 5 divided by 2 is 2.5. 12.5 divided by 2.5 is equals to 5. 5 is equals to 16D plus 4D, which is 20D, and D therefore will be equals to 5 divided by 20. 5 divided by 20 is 0.25. Our A is 8D. 8 into 0.25 is equals to 2. So the terms will be 2, 2.25, 2.5, 2.75, and 3. A will be our answer. Moving to 4.28. 4.28 says that the pth term of an AP is 1 over q. We know that any term in an arithmetic progression is denoted by a general formula, which is term n is equals to a plus n minus 1 d. Our n term or pth term is 1 over q, will be 1 over q is equals to a plus p minus 1 into d. Likewise, it says that qth term is 1 over p. So 1 over p is equals to a plus q minus 1 d. This is q. And we have to find the sum of pqth term. Let's first find a and d in terms of p and q. This is one equation and this is the second equation. If we subtract second from first equation, we will have, or if we subtract second from first equation, we will have 2 minus 1, which will be 1 over p minus 1 over q is equals to a minus a is cancel out, q minus 1 d minus p minus 1 into d. Now if you take d common in right hand side, we will be left with q minus 1 minus p plus 1, and on left hand side we will have q minus p over pq. So our right hand side will now become q minus p, because plus 1 minus 1 are cancelled out, and over left hand side we will have q minus p over p q. Q minus p and q minus p will cancel out, d will be equals to 1 divided by p q. Finding out a in terms of p and q, we can pick equation number, any equation we can, let's say pick equation number 1. Our equation number 1 will be 1 over q is equals to a plus p minus 1, and we now know our d is 1 divided by p into q. And now if we bring everything on left hand side except a, this will be 1 over q minus p minus 1 over pq is equals to a. Or if we take LCM, a is equals to 1 divided by, sorry, a is equals to, this pq will be our LCM, so a is equals to p minus p minus 1, which will be minus 1 over plus 1, because this is minus, this will become plus 1 over pq. We now have our a and d in terms of p and q. We are supposed to find sum of pqth term, which will be n is pqx term, so pq over 2, 2 into a is 1 over pq plus n or pq minus 1 into d is 1 over pq. Now if we solve this, it will be sum or pq is equals to pq divided by 2, in bracket we have an LCM of pq, which will be 2 plus pq minus 1. This will finally be sum of pq is equals to pq divided by 2, and in bracket we have pq plus 1 over pq. pq and pq will cancel out, so our sum will be pq. Sorry, this is minus. Okay, it's fine. It will be pq and pq will cancel out, so we will have pq plus 1 divided by 2, or it can be written as 1 divided by 2 common pq plus 1. So our answer to 4.27 will be, sorry, 4.28 will be A, 1 divided by 2 into bracket pq plus 1. Moving on to 4.29. 4.29 says that the least value of n, we have to find the least value of n, or the lowest value which n can take, for which the sum of n terms of the series 1 plus 3 square is greater than 7000. Now this is an geometric progression, since the first term is 1, the second is 3, the third is 3 square, and the sum of geometric progression is denoted by a formula which is Sn is equals to a r power n minus 1 divided by r minus 1. So to find out the sum, we can use this specific formula. Sn is equals to a into r power n minus 1 divided by r minus 1, and it says that we have to find the least value of n for which the sum of this series is greater than 7000. So the condition is a r power n minus 1 divided by r minus 1 is greater than 7000. A is the first term is 1, r is the ratio is 3 minus 1 divided by 3 minus 1 greater than 7000. After that, if we solve it, we will get 3 power n minus 1 is greater than 14,000, and 3 power n is greater than 14,001. Applying log on both sides, which I will not be applying over here since we have studied it already in class, the n value will come out to be n is greater than 8.68. Now since n is a whole number, it is a term, so n will be equals to 9. Our answer for 4.29 will be 4.29a. The log properties are discussed in a separate video as well, so our answer to 4.29 is A. Moving to 4.30. 4.30 says if the sum of infinity or infinite terms, unlimited terms, in a GP is 2 and the sum of their squares is 4 over 3. The series is, what is the series? The sum to infinity formula is S is equals to A divided by 1 minus R. Let's say our first term is A, second is A R, third is A R square. So it says that sum to infinity is 2. So 2 is equals to A divided by 1 minus R, or we can say A is equals to 2 into 1 minus R. It further says that if all the terms are squared, the sum of their squares means first term is made A square, second term is AR square, AR square is A square R square. The third term is AR square whole square, which is A square R power 4. It says that the sum of their squares means if we sum all of these, it will be 4/3 of the series is. So the sum is 4/3. Again, sum to infinity formula is S is equals to A divided by 1 minus R, where A is the first term, and now my first term will become A square. a square will be my first term. Likewise, now my r will be second term divided by first term. Second term divided by first term gives me r square, so my r will be r square, and this sum will be 4 over 3. We have got this condition. From the first equation, or from the first condition, we know a is equals to 2 multiplied by 1 minus r. So we can substitute it over here. If I cross multiply, this will be 4 into 1 minus r square is equals to a. From my first equation, I know a is equals to 2 1 minus r, and it is in whole square as well, and multiplied by 3 because we cross multiplied. So this will be 4 minus 4r square is equals to, on the right hand side we have 4 1 minus r square into 3. This will be 4 minus 4r square is equals to 12. 4 into 3 is 12, and expanding the bracket, 1 square minus 2 into 1 into r plus r square. Now further solving it, 4 minus 4r square is equals to, on the right hand side we have 12 minus 24r plus 12r square. Bringing everything to the left hand side, we have 16 minus 16r square plus 24r minus 8 is equals to 0. Simplifying it, dividing everything by, let's say, minus 4. So this will, or minus 8. So the first term will become 2r square minus 3r plus 1 is equals to 0. Breaking the midterm, 2r square minus 2r minus r plus 1 is equals to 0. Taking 2r common from first two terms, r minus 1, and minus 1 from second two terms, r minus 1 is equals to 0. 2r minus 1 is equals to 0, or r minus 1 is equals to 0. R will be equals to 1 over here, and over here r will be equals to 1 over 2. Now finding the values of a, we derive the equations of a is equals to 2 into 1 minus r. So a will be 1, 2 in 1 minus half, and a will be equals to 1 minus half is half. Half into 2 is 0, which is not possible. Since we were calculating the sum to infinity, and it is not possible since sum to infinity formula has a in the numerator. And now if r was 1, our a will be a is equals to 2 into 1 minus 1. So over here, sorry, in the over here our a will be become 0, and it will not be possible. However, over here a will not equals to 0, it will be a is equals to 1, which will be our answer. So r is half and a is 1, and we were supposed to find the terms. Our a is 1 and r is half. So the terms will be, first term is 1, second term will be a into r is half, third term will be a r square is 1 over 4. Our answer to 4.30 is A.